Students, today we are going to solve problems on series RLC circuit. Okay, as already we discussed, we know that an AC circuit contains all the three elements, that is resistor, inductor and capacitor. What is the effect of current, voltage and power in case of RLC series circuit in the previous class. In this class, let us discuss the problem on series RLC circuit. So the problems goes like this. A single phase voltage source having in voltage of 200 plus J0 volt. Here the voltage will be given in rectangular form. So we can write this voltage in polar form also we can write. At 50 Hz is applied to a circuit comprising of a resistance of 20 ohm, inductance of 20 millihenry and a capacitance of 150 microfarad connected in series. Find the following parameters. One is impedance of the circuit, current drawn from the supply, power factor, power drawn and also the drop across the various elements and also energy stored in the inductor and capacitor, and also draw the phasor diagram. Okay, this is the problem. So first, before solving the problem, we can write the series RLC circuit. Okay, so I will write the circuit R. I will increase the font size, okay, for more visibility. Then L, then C is connected across the an AC circuit which contains all the three elements. And what is the voltage is given? What will be given at rectangular form? So it is nothing but 200 at an angle 0 in polar form. Also you can write 200 plus J0, both are same. Okay, its magnitude is 200. And what is the value of resistance? Resistance value is 20. Inductor value is 20 millihenry. Similarly, the capacitor value is 150 microfarad. 150 microfarad. Now we have to calculate the drop, that is the power. Okay, voltage drop across resistor, drop across inductor, that is VL. Similarly, the drop across capacitor is VC. Okay, and we can solve the problem. Okay, it goes like this. Then what is the value of L is given? L is 20 millihenry. So L is 20 millihenry and capacitance C is 150 microfarad. As it is an RLC circuit, we have to find the impedance. So first, so that's why we are finding the XL and XC values. What is XL? XL is equal to 2 pi FL. So which is nothing but 2 pi. The frequency is given. If it is not given also, you can assume it is given now 50 Hz. 2 pi into 50. Now the value of L is 20 millihenry. 20 into 10 to the power of minus 3. So you will get, simplify, you will get 6.2831 ohms. Okay. Similarly, calculate the XC value. XC value is equal to 1 by 2 pi FC. So simplify, 1 by 2 pi F50 into 150 into 10 to the power of minus 6. So its value will be simplified, you will get 21.22 ohm. You know the resistor now. So automatically, how to calculate the impedance? So impedance is equal to, how to calculate impedance? So Z is equal to root of R square plus XL minus XC square. Okay, so I will take directly R plus J into XL minus J into XC. Simplify directly. So I'll substitute here. What is R? R is 20 plus So J XL value is 6.2831. Here you can observe the values of XL and XC. Which value is more? The XC is greater than your XL. Then generally it is actually acts as a behave like a RC circuit. You can observe here XC value is greater than XL. So while writing the phasor diagram or vector diagram, you should keep it in mind. Here you have to observe these values. Okay, so these values are very important. These values you can compare. Now XC is greater than XL, then power factor is leading, current is leading the voltage. Okay, you can keep it in this mind. So now I am doing the simplification. Now J is XL is 6.2831 minus XC is 21.22. Now you will get do directly addition subtraction now. So Z is equal to 20 minus, so 21 minus 6 is around 14.9. So 14.9369 ohm. This is the impedance value. Convert this into rectangular to polar form. Now what is the Z value? So Z value in polar form is equal to 24.96 at an angle of minus 36.75. This is the impedance value. So this is the first point of the given problem. Calculate the impedance. Now we have to calculate the current drawn from the supply. It's very easy. As Ohm's law, how to calculate the current? I will take it in different color. Okay, this is the first bit. Now I will take with second bit. So second bit I will take. So second bit. So current drawn from supply. So I is equal to V by Z. Because why we are considering impedance? Because circuit contains all the three elements. So the total opposition is impedance. So I is equal to V by Z. So when we are doing the division, we can convert both the V and Z value should be in polar form. As we discussed already, we know that 200 at an angle 0, 200 plus J0 can be written as 200 at an angle 0. And what is the impedance value? 24.96 at an angle of minus 36.75. Okay, so this is when you do a simplification. So you take this, okay, divide this and get the answer. When you take this angle to numerator, this angle becomes 0 plus 36.75. So 200 by 24.96 will be around I is equal to 8.0121 at an angle of plus 36. Why? This will go to numerator. This becomes positive. So 36.75. Okay, this is the value of I. This is the second bit. Now as I said already, okay, so the XC value is greater than XL value, then it is a capacitive circuit. Now what is power factor? Power factor is, what is that power factor? What is the formula? There are three definitions, okay, with respect to power, with respect to impedance and resistance, and with respect to voltage between, okay, angle between the current and voltage. Now, so I will use another formula now for power, okay, so sorry, for cos pi. So I will take that third one. Cos pi is equal to, simple formula is R by Z, because we know R and we know Z value already we are calculating. So I will take this, okay, R by Z. So R is equal to 20 and Z value is 24.96, okay, 24.96. So if you do this, you will get around 0.8012. Okay, 0.8012. 1 2. Leading or lagging? It is because of RC circuit. This is leading. This is leading. Power factor is leading because XC is greater than XL. Okay, XC is greater than XL. XC value is 21 and XL value is 6. So 21 is greater than 6. Obviously, then it's a RC circuit. When it is an RC circuit, current is leading the voltage. So therefore, power factor is leading. So this is the third important determination. Now next we have to calculate the power. We have to calculate the power and also drop across the individual elements. Now I will go with the power equation. Power equation is V into I into cos pi. So you know all the values now. You know V, substitute 200 and current is how much? 8.0121 and cos pi. You can take that cos pi value is how much? 0.8012. So you simplify, you will get around power is 1283.843 watts. This is the equation for power. Okay, so next we have to calculate the drop across individual elements. Drop across individual elements. Very simple. Applies the Ohm's law. What is the drop across resistance? VR is nothing but current multiplied with the resistance value. So VR is nothing but I into R. So what is the value of current I? 8.0121 and resistance value is 20. So its drop is around 160.024 volts. Okay, similarly what is the drop across inductor? That is VL. Drop across inductor is VL. VL is nothing but I into XL. Similarly, a drop across capacitor is VC. That is given by I into XC. I into XC. We are already calculating all those things. So current is same, 8.0121 into XL value is how much? 6.2831 already calculated. So you will get around 50.34 volts. 50.34 volts. Similarly, what is the drop across capacitor? I into XC. So substitute I and XC value. So you will get around drop is 170.0167 volts. 0.67 volts. Now you have to draw the phasor diagram. Similarly, also we can calculate the energy stored in inductor and capacitor. Energy stored in the inductor is given by EL. That is nothing but half into Li square. If you want, you can calculate. And energy stored in the capacitor is EC half into C into Vc square. Okay, this is the value. You can substitute, you will get energy stored in the inductor and capacitor. So energy stored in the inductor, substitute, you will get around 0.642 joules. In case of capacitor, you will get around 2.168 joules. Next, very important is draw the phasor diagram. Draw the phasor diagram. Okay, as we know here, in the given circuit, because of XC is greater than XL, it acts as a leading circuit. It acts as a RC circuit. Current is leading. Current is leading. Now I will draw the vector diagram. So now I will take current as the reference vector. Okay, so as we know, what is the drop in the resistive circuit? Current and voltage are in same phase. So therefore this is VR. Okay, VR is how much? What is the drop of VR? VR drop is how much? Almost it is 160.02 volts. Okay, then what about VL? So VL is how much? Current and voltage are actually automatically here. Voltage is leading in case of inductive circuit. So therefore, so the VL is 50.34 volts, and VC, again current is leading the voltage. This is VC. So VC is equal to 170.016 volts. Okay, now but we have to calculate the resultant vector. So what is the resultant vector? As we know, based on the circuit, we will come to know it's an RC circuit. So therefore current is not exactly leading by 90 degree or not lagging by 90 degree if it is RL circuit. Now it is in between, the angle is in between the 0 and 90 degree. So therefore I have to calculate the resultant vector. Now it's a VC. Now I have to draw the perpendicular line, okay, with VR and VC, and I have to draw the resultant vector. So this is the resultant vector. Okay, so the angle between the voltage and the current is how much? Cos pi is 0.8012. So you will get around 36.75 degree. 36.75 degree. So that is cos pi is 0.08. So take the value, you will get around 36.75. So this is the resultant. This V is nothing but VR plus VL plus VC, and this value, okay, this is VC now. This is VC. VC is equal to 170.016 volts. Okay. Because I have to draw that. Now this is the resultant. This is VL, vector VL plus vector VC. So that is resultant voltage V is equal to this VR plus VL plus VC. So this is the voltage V. You can substitute. So you will get all the values put together. You will get V is equal to how much? 200 volt. That we know. Okay, that is given in the given problem. That is around 200 volts. So with this, I'll conclude. Okay, the problem, this kind of problems are very important in examination. Please go through it. If anything, we'll come back to next. Any doubt, we can come back to next class. Okay, thank you.